Welcome to this week's edition of the Pentair Water Break. Thank you very much for joining us on this Friday afternoon. And last week we introduced the EIQ controller and had to upgrade that to our existing units. The wonderful thing about this upgrade is it doesn't change anything on how you go about troubleshooting the wet portions of these valves. And with that being said, let's go ahead and get started with this. So the three valves that we're going to upgrade from their existing format to EIQ, you have the 255 and the Proforma, and you have several year classes of controllers here. This is all going to be updated in the future to the EIQ, and as things fail, controllers fail in the field, you'll need to replace them. It's a real simple upgrade. It's cover and controller swap. So new cover, new controller, just an easy trade out. No tools required. Just swap the correct pin plugs from one connector to the other on the board, and you're ready to go. And if you use the programming features, you can just plug in a USB stick to the new EIQ controller and upload your programming there. A changeover that should take no longer than 10 minutes to do. So when we talk about Autotrol valves in the industry, we have piston valves, we have rotary valves, and we have Autotrol, which is a seal disc or basically door style valve, or opening and closing individual doors to manage water flow. That's how every softener works, managing water flow. The wonderful thing about the Autotrol platform to me, looking at it from a technician's perspective, is all the really serviceable parts for maintenance and inspection are easily accessible on the outside of the unit with a minimum of tools. If you get an appropriate torque tool, head tool to fit this, either from one of our distributors or a local tool store, this will service all the Autotrol plugs on all of our units. The 255 has an air check valve on the side of the unit, so you don't need the air check in the brine tank. And this does quite a few things for us from a troubleshooting perspective. We'll see if the unit's drawing air during brine draw right here in this unit, and you can see whether or not you're drawing a lot of debris out of your brine tank as well. Great visual, quick inspection for a technician. If you need to access any of the ports here, the injector and cap, directly on the outside, you just bypass the unit, depressurize it by pushing it into regen to relieve the pressure off the head, and now you can address those components. You have a single piece cam that sets the order of operations in these valves. So the cam is fixed, and so is the order of operations. The only thing we change on an Autotrol valve is the duration it's in one of those functions. You have your manifold connections at the back, your drain, and your plumbing ports there for easy access if you need to. You have your refill control, which is tunable on some units directly from the outside. If not, you may have to replace this with a different control depending on the unit. So the other great thing about Autotrol is the forethought of the service professional. Here, if I have, let's say, an issue with hot water backup, I can depressurize the unit like I do before always servicing a unit, unscrew one screw and pull this pin, and the entire top portion of the valve can come off and be replaced. I just need to make sure I validate O-rings and proper fit in the lower plate, but no taking it off the tank to replace the water control portion of the top. That's rather convenient in case you pull a riser tube, right? You can access the injectors here. Same situation with anyone's injector. Make sure they're free and clear and that port's free of debris. If you ever get black rubber on your fingers from touching an O-ring, it's a sign that it needs to be replaced. And if that's the case, I'm going to replace the entire injector at this point in time. You can see the screen here for capturing debris out of the brine tank. Very, very easy to access these, clean these with a soft toothbrush or running them underwater. And here is the drain line flow control and the brine line flow control is right here. These flow controls, it's actually this piece here, the cap. That's the flow control. And this is a check ball. You want to make sure these check balls are flexible, but not too squishy, but also aren't too firm. It's kind of a happy medium. And I would suggest these balls and injectors should be changed when you're changing the seal and spacer discs on these units. Why? They're wear items. You can see here that these units are heat welded together and how easily accessible the three main components you're going to troubleshoot most often are accessible. These gates right here insert to the top. Essentially, if you have water on top of this, this is where it's going to be leaking from, and you replace them all. There isn't just replacing one. I wouldn't go that route. Why? They all have the same wear pattern. You also can see here that locking bar again with the screw, how it molds into place. You have your optical sensor and camshaft. One of the things you have to make sure you do to ensure proper order of operation is there's an arrow on the top of this cam that aligns with an arrow in the head. If you install it that way, this unit will work properly. Something to double check if you can't figure out what's going on. The motor is accessible from the back on all these units. Just pop out a little plastic pin and access the motor. Disconnect it and replace it. Very, very easy to service. That optical sensor is right up front. You want to be, when you're installing this cam, you need to be aware of that optical sensor. You have to slide the end of the cam in between the two probes to make sure it reads properly. But a very, very simple way to control the cam. Now the 255 here, once you remove the cam and get access underneath, this is the order of the operations of the gates or seal plates involved. You have the first one's regenerate, inlet or outlet, and bypass, backwash, drain, and rinse. On these units, if you're leaking to drain, you can just manually push these forwards and see which one it is. In that case, I am probably going to replace the steel spring on the head. Those steel springs on these units do wear out in time. If you've ever taken a piece of wire and wiggled it back and forth until it breaks, that's eventually what happens with these pieces of metal, is that flexing back and forth weakens them over time, and they will lose that ability to hold that gate closed. So if you're replacing the seal and spacer discs, replace that spring. If you're over 80 psi in the building, I would suggest adding a second spring on top to help resist that back pressure. And if you're going up multiple floors, I would also recommend using a check valve on the outlet of these units to make sure we can keep these valves hydraulically balanced, because they are water pressure balanced internally. Also, you can see where your bypasses are. If you've got a bypass, you can push a disc close and test again and see if that's the issue, so you know exactly what it is. But if I have a bypass or a failure to draw brine in one of these units or a leak, I'm just replacing all of these anyways. So it typically has to be a fairly significant repair for these to be replaced. The performer valve is just the big brother of the 255 without that clear port on the side, but it's for higher flow applications. Same easy access to all your components on the outside. Your meters are here internal to the body of both of these units, and it allows you to pull those out once you disconnect them and check them, or you can check your sensor right here just by running a magnet over the end of that sensor. It should indicate a water drop on the screen if you run a magnet over your sensor. If it does not, your cable or your control is bad. You need to be replaced. Start with the cable. Same one-piece spring, same sort of issues with that spring in the field. If you're dealing with high pressure installs, make sure you put that on there. And water hammer is a big concern with a hydraulically balanced valve. Remember, a water hammer will give you a spike up to 10 times the incoming water pressure. So even at 50 psi, you can get a bump up to 500. Right. So if you've got any kind of concerns about water hammer in the building, a check valve on the outlet of these units is helpful. Also, a water hammer arrestor would be great as well to help these operate more efficiently and effectively. That different cam, it's longer, different body, but does the same job. Your refill control is here. You can just dial the amount of water up if you need to brine more without really changing much. Don't even have to access the programming there. The camshaft is here as well. It pops backwards to remove. The motor is the same access and motor. The outlet is where the meter is internal here. And those same star fittings that you can use to remove. If you don't have one of those Torx, a wide screwdriver will work, but you may damage that plug, and that's always a risk. So we recommend the Torx screw. I've forgotten tools before and have even pounded a piece of copper tubing flat on the end and used it as a screwdriver to pop it open. But that's technicians, right? So prefer the Torx screw, but you guys will use what you need to use in the field as always. Same sort of deal with the optical sensor. Make sure it's aligned in that head so it reads properly. Backwash, drain line flow control here. Remember, this plastic piece that you unscrew is the flow control, not the check ball. And here you can see the valve disc order of operations for Autotrol. This is another reason why it's great to carry a manual with you, because it has this in it for a refresher. If it's leaking to drain when I arrive there, it's going to be one of these paddles. And if I push on it and it closes it, I know that's my problem. If it's only a slight bit of pressure, I'm going to replace that spring or add a spring on top of it. If that doesn't solve it, I'm going to replace those seals. Those seal discs. You have a bypass valve here. Well, we'll get into that in a minute, that you can add later, but here you can tap your regenerate valve and fill the tank, see how that's working, check for leaks. You have your outlet valve, your inlet valve, drain and rinse, so you can operate these functions manually without waiting for that control to turn. So here's what it looks like in real life in the color here. It's heat welded as well. The flappers, the seal discs, the doors, whatever you want to call them. Oh, let me go back here. But you can see same screen, same check balls here, same type of injectors, right? These are common components shared across the platform. Very, very easy to reach. At the end of the Proformas cam, you will read the position. Treated water, normal operation, that's service. You have your different cycles here. And notice that these cycles are gone through, but they're just not used in filter mode. They're just bypassed. But if this isn't aligned properly in the cam, you'll be in the wrong cycle. So understand this is key to getting the operation correct. We have a family of injectors pre-sized per tank for softening. If you are doing other medias, reach out to tech service and they'll help you with that. But this is for water softening medias. Preset, you're not figuring any of this out. We use this performance from these injectors in the programming. And the thing about the EIQ and the logic controllers, they do a lot of that math behind the scenes for you versus other valves on the market. Autotrol likes to keep it simple for technicians. That's why it's such a simple, robust valve. Now, for troubleshooting, if you want to evaluate your brine system, you can do it a couple different ways. You're going to do visual inspections, like let's say you've got air to service in the house, you're not drawing brine, not getting a good regen. With the 255, you'll see that air draw in that side safety jar there with the air check. And in a pro forma, you're going to listen for that gurgling sounds and those sorts of things. But if you want to know you're getting the proper flow rate, you can do this one of two ways. If you have access to the drain line, you can measure your flow rate there with a graduated cylinder or a well-marked bucket. I use a 5-gallon water jug that I've graduated by the quarter gallon all the way up so I can measure this effectively. If I have flexible hoses, I can just pop it in. If I don't, I have to use another method. And at the end of the brine, at the waistline, we can measure flow. From brine draw to slow rinse, we're going to get the total flow out that waistline. So if I have 60 PSI on site in this type L injector, I'm going to go up 60 PSI, and I should be getting between 1 and 1.2 gallons a minute here. So 1.1 gallons in a minute. If I'm getting that out my waistline, I know my brine system is operating properly because it's drawing properly. Then I can check the next minute, go down here to rinse on the same line, and the next minute I should be getting about 0.6 gallons per minute for just rinse. And if that's flowing properly, I know my brine system is operating properly with no defects because I'm getting the proper specs out the waistline. If I don't have access to the waistline, I can time the brine draw out of the tank. So let's say I got a 1 cubic foot unit and I'm brining at 9 pounds per cubic foot, 3 pounds of salt per gallon of water. So I have 3 gallons of water in my brine tank. Well, if I go here to 60 PSI and go up to brine draw, that's just over half a gallon a minute. So I've got 3 gallons of water divided by a half a gallon a minute, about, for simplicity's sake here, that gives me 6 minutes. So once I hit the regen and it kicks into brine draw, I can time how long it takes until that safety check seals. And if that's within my right at my 6 minutes, I know it's drawing properly and I don't have an issue with my screen or my unit. And I've not touched anything but my phone to look at a clock here or trap some water at the end in a bucket and timed it. So it's how you evaluate without touching tools and creating leak points. Very, very powerful. And this applies to everyone's softeners. They will have injector charts for their units as well. Now, the most critical thing in all of softening, no matter whose product you use, is getting a good backwash. Let me double check questions here before. All right. Is double checking the backwash. This should be done at your annual visits or right after a follow-up visit after installing a unit. Autotrol gets used in a lot of rough water conditions because of its design, and managing your backwash will prevent a lot of nuisances. Why? If we don't get all the dirt out of the tank, where are we leaving it? It's not just going to be in your tank, it's going to be in your valve. And any physical obstructions, dirt, and debris is going to cause issues. So this chart is the science behind all backwashing systems, regardless of the industry they're in. If your flow control is sized properly for your unit, you should see essentially 2 bed volumes of water in 10 minutes to backwash that tank. If you get debris the last 2 minutes of your backwash, it's not long enough or good enough to get the job done. Add 5 minutes to your backwash. If you don't, you're going to leave that dirt in the head of the unit. You're actually testing it after it comes out. So understand that we get a good backwash, our valve body stays free and clear of dirt. Our resin is in a state that it's going to regenerate as well as we can get it in that circumstance. So backwash is critical. Secondly, I like to take in residential situations, 2-ounce shot glasses and take a sample every minute. This does a bunch of things for me as a technician. Most of all, I sell on facts, not trust. I'm going to catch the dirt load and any resin beads coming out of the tank. If it's a whole lot, I know I have some damage inside the unit and need to go find it, either in the riser tube or the connection to the valve itself. If I get a bunch of broken beads and the unit's been in service, 5-7 years, that's osmotic shock. That's telling me that we're regenerating frequently enough that the beads are starting to crack, and I'm going to see those there. The other thing you'll see is sanitizer breakdown of resins as you start to get that applesauce looking mush coming out of the tank into your shot glasses. And you'll also see this curve matched out in dirt load on your brine tank as you set these up. And this allows you to sell off this information. Do I need a rebed? Yes, with applesauce. And it also tells me I probably need activated carbon at that location as well to protect the softener. And if I adjust this, the next time I'm out, I'm going to have less failures with this unit because the valve itself is cleaner than it was prior. Autotrol is an excellent dirty water valve. It takes on aggressive regenerants if you need them very well, because we have so few moving parts that in the water column, and those are generally impervious to sort of chemical damage long-term as other things are. Here you can see the access to those flappers. In this little channel here, there's one on both heads. That is the bypass that you can install. We'll show you what it looks like here in a second. These are the flappers, and this is how these doors work. The camera rotates by, opens the door. This is, if you've ever seen a river spillway dam, this is that upside down. And this flow creates turbulent action as it leaves, scrubbing the face of these seal discs. This is why we want to backwash really well. Why? I don't want to leave dirt up in here. That's it. That's my sealing surface. I want to get this free of dirt. Lots of shared components between these two units. In the future, this will be your EIQ and the EIQ cover, but all the plugs are the same. The ports are the same. The screens are the same. The injectors are the same. You're going to have a different spring and a different cam and different valve bodies. You can convert these very easily from softener to filter with programming change in a few components. If you're going to convert a softener to a filter, you need the plug right here. And you can see this is a flow control, this is a plug, this is a flow control. Flow controls have these little slots in them. This is the accessory. If you have those people that don't like the super slick feel of soft water, you can drop in this little square screw, add this fine thread screw to tap open the bypass door a little bit, giving a little bit of a blend that you can tweak. Add a drop of glue or something here, like Elmer's glue that's going to break when it dries, to hold it in place, to keep it in place so no nuisance issues there, but very easy bypass to use. And then if you're dealing with confined installs, the turbulator allows us to shrink the amount of freeboard by giving us backwash both at the top and bottom of the tank. That throwing dirt out only requires 8-inch of freeboard, and that will save you a lot of expense on tank height that you wouldn't have to spend in tighter locations, or get you into a tight location you might not have gotten before.